Today we're going to be talking about scatter plots. And a scatter plot is a graph of paired data in which the data values are plotted as XY coordinates. Okay, so we talked about yesterday about XY coordinates and a coordinate plane. A scatter plot uses the first coordinate, or the first quadrant, excuse me, of a coordinate plane to graph data. So in this case, we know that the dependent variables are on the y-axis and the independent variables are on the x-axis. Alright, so when we're looking at a scatter plot, oftentimes there's something called a correlation, okay? And a correlation is the degree to which two variables are associated. So what that means is when you're looking at um, a set of data and you've plotted it on a scatter plot, for instance like this, you have all this data plotted, and there's usually a trend or a correlation on how the data is being displayed. So for example, there are three different ways it can be displayed. Oftentimes there's approximately no correlation, so a relationship in a paired data in which there is no apparent pattern. So for example, in this case, there's really no pattern. You see all these little dots. They're kind of they're all over the place. All right? There's also negatively associated data in which the values tend to increase when the other decrease, okay? So for example, a negatively associated data would be going down, okay? So you see all the little red dots, they tend to decrease, okay? There's also a positively associated data where the data actually increases. So the relationship in paired data in which the two sets of data tend to increase together. So for example, we have a graph here. So as this data increases, this data increases. So you get this line, okay? So let's practice real quick. So we have positive, negative, and no correlation. So if we look at this scatter plot here, think about it. Think which section it would go to. If you said no correlation, you are correct. Okay? All right. Same with this one. Okay? Now, if you look at this one, you will notice that the data tends to go up, so that would be over here. Okay? In this case, we have another no correlation. Okay? This one, you can see the dots tend to go down, so that would be a negative. Okay? Now this one's a little difficult to see, but because they all seem to be in the middle. But if you notice, one's way up here, one's down here. Okay? They do very, very slightly tend to go negative. Okay? This one tends to go positive. All right? So you get the point. Okay? All right. Now, when you're looking at this data and you're seeing the correlation, um, there's something called the best fit line or the trend line. They're the same thing. Oftentimes, you will hear them in both ways. I know in your book they talk about trend lines. Okay, so a line of best fit is a straight line drawn through as many points as possible with approximately the same number of points above the line as there are below the line. Okay, so if you see here, this has a negative correlation. Okay, but the best fit line kind of it goes right through all of that data. Same with this positive correlation. It tends to go right through. You cannot find a best fit line on a scatter plot that has no correlation. Okay, so this this would be the positive, and this would be the negative. Okay? All right. Um, so here we have an example. The data below shows the relationship of hours 7th graders study in a week and the grades they receive on a math test. So if you see our table here, we have hours studying per week. So we have like 0.25, 0.751, so on and so forth. And then the percentage they get on a math test. These kids apparently aren't doing very well in math, as you can see. All right. So we would take this data and we would plot it on the graph. So for example, um, as you can see on my x-axis, we have hours studying, and on my y-axis, I have the percentage. So I'd match them up. So I have 0.25, so that's about here for hours, and they got 20, okay? About 0.75, that would be about here, and they got 25, all right? So you would go through and plot all those points, and your graph should look um, something like, oh, I don't have the graph. Never mind. If you went through and you actually graphed all these points, we can just do it together now. Sorry, I thought that I had it already made. So then we would go 1 to 40. Okay. 1.25 would be also 40. Okay. 1.5 would be 50. Okay. 2.5 would be 55. And 2.5 again, we have 60. All right, now if you look at our data, you could say that this is a positive correlation, okay? So we graph the data. Our step two would be to draw the line of best fit. So in this case, I'm just going to use my line tool. All right, and I would probably make it about here, okay? About there. And then our step three would be to figure out if we were to if a child was to get 90% on a test, how many hours per week? So if we extended our best fit line, if I were to keep going, okay? If I were to look at 90%, how many hours per week would they actually have to study? I would say about 4.25, okay? So it would be about 4.25 hours that they would have to study, okay? All right, so we're going to work on scatter plots tomorrow. Make sure that you understand all the vocabulary and the correlations of the scatter plots.